Okay class, this is question number 2 of assignment projection of solid. A pentagonal pyramid of 30 mm edge of base and 60 mm axis height is lying on one of its triangular surface in the VP so that the axis is inclined at an angle of 45 degree to HP. Draw its front view and top view. So class, as per the given condition for first stage, the pentagonal pyramid is lying on one of its triangular surface in the VP. That means class, we assume the whole base of the pentagonal pyramid is resting on VP. And now class, how we will place a pentagonal shape in VP? It is resting on triangular surface. So class, we have only one option. If I draw pentagon like this, so this is the triangular surface. In second stage, the pentagonal pyramid is resting on this triangular surface. That means the base edge should be towards right. So now we will draw a pentagonal which have a dimension of base edge 30 mm. Okay. Now draw major angle from both the end of the line 54. Now join these 2 points. This is your apex position. Now consider apex position as center and this much as radius, and draw a circle then measure base edge dimension 30 mm over the compass and cut on the circumference. Now join all points. Okay, now give naming. This is apex, O dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash. Now extend all points vertical downward up to the reference line XY and extend apex position Now class, the height of the pyramid is given 60 mm. To measure here 60 mm. Now join slant height. Now class, this is your O, this point is your 2, this point is your 3 and 5, this point is your 4. Okay, so now class, the second stage condition is it is lying on one of its triangular surface. So this is the triangular surface projection in front view and this is the triangular surface projection in top view. That's in class. It is lying on triangular surface. That means class we have to tilt this object like this. That means the O2 should be lying on reference line. So the class, suppose class I am taking two, then measure O2. In class C, in top view, O2 and O4 are different in length. To make sure you are measuring correct slant height dimension, O2 is different length and O4 have different dimension. Then measure base. This point is your 4, this point is your O. Now join 2, 4, O4, O2. Now mark all points of the base over this figure. Now measure class 4 and 5. 4 and 5. And the center position at okay. So class, this point is your 5, 3, and this is the axis. This is your axis, long dash, short dash. Okay. After that class, we will extend all points of the top view in second stage vertically up. light and shade. After it, class extend all points of front view towards right. Now class, this is the projection of O, and this is O. This is your O dash. Now class, start from 1, projection of 1 and projection of this is the projection of 1 dash. Now projection of 2, this is the projection of 2, this is 2 dash. Now 3, projection of 3, projection of 3 to this point is your 3 dash. Now projection of 4, projection of 4, this point is 4 dash. Projection of 5, projection of 5, this point is your 5 dash. Now class, the observer is here. When we see this object from this side, whole base of the pentagonal pyramid and the whole slant height is visible to the observer. So the outline of the object is completely visible. Okay, so now class, see the outline of the object is completely visible. We will draw first. Later on class we will decide which lines are hidden. So now you can see class O1, the 1 point, it is the distance of 1 is far from the observer, but the distance of 4 is nearest to the observer. That means class 4 point is completely visible, but 1 and 2 should be not. We will draw a hidden line for this. Because class on that surface the object is lying. This is the required triangular surface O1, 2. Okay. Now class, for third stage condition, so that the axis is inclined at an angle of 45 to the HP. So class, whenever in the question the statement is like this, the axis is inclined, that means we are that means it is the true axis, true length of the axis. So now class, this is the true length of the axis and this is the elevation length of the axis. So but by seeing this object we have to draw a final stage of the object. So that's why we need to draw a locus projection of true shape. So how we can do class C? First we will take, suppose this is the line. Okay, suppose I am drawing here class. First take single line, then measure 45. Now measure true axis length from the top view and cut on the line. This is the locus of point. After that class, we will measure elevation length of the axis from the front view and we will cut and join. So this is the same concept which we followed in projection of line. This is true length, this is planned length, sorry, elevation length, right? Or we can say front view. So now class, this angle is 45 or it is alpha, or this angle is your class theta, angle made by HV with. So now class, we need to measure this angle theta. It is coming class, it is coming class 50. So your theta is 50. Okay, so that's in class. The new axis we will draw at an angle of 50 theta. Okay, sorry class, this is your alpha, this is your theta. So 50 is your alpha, theta is your 45. So now class, new axis as per auxiliary inclined plane method. This axis is inclined at an angle of 45. So instead of rotating this axis or redrawing this front view, we inclined a new reference line at an angle of 50 degree. Okay. So now class, we will measure here. Now measure angle here. This angle is your 50. Okay. So this is your new reference line. This is alpha x1. Now we will extend all points of front view towards new reference line at an angle of 90. That means all lines are perpendicular to the new reference line. So now extend, and make sure class whenever you extend all points of the front view over the new reference line, it should be light in shade. Don't draw dark. Then 5, then 1, then 4, then 2, then 3. Okay. After that class, we measure the respective point distance from the top view. So now class C, O and 2 are lying on reference line, previous reference line. That means class in the new reference line, O also lying on reference line, and 2, the projection of 2 also lying on reference line. Then class we will measure 5 and 3. See class how to measure. This is 5 and this is 3. A distance of 0.53 from the previous reference line, vertical distance. Then respective 5 and 3 point we will mark. This point is your 5 and this point is your 3. Now measure 4. Again I'm saying C class 4, that distance. Then projection of 4. This is projection of 4. And class C 1 and 2 both are lying on the reference line, so 1 point also on reference. Now class join. So now class C, observer is here. When we see this object from this side, the whole base is completely visible and the apex is also visible. That means class the outline of the object is completely visible. First we will join the outline of the object. but class O3 is hidden, then we will draw O3. So class, this is your complete solution. So one point to remember here, class, when in the question it is given that the axis is inclined at an angle of 45. Axis, that means class, they are talking about true axis. That in that case, class, we have to draw a locus projection to finding out the inclination of elevation axis with respect to the given angle 45. So theta is here 45 and the elevation axis making an angle of 50 degree with xy. That's why we inclined the new reference line at an angle of 50 instead of 45. If in the question, class, you incline the new axis reference line at an angle of 45, so your third stage is wrong. So make sure you need to find out alpha here.